Perhaps you remember the dreaded merry-go-round. Courageous children would hold on for dear life as their colleagues would spin the apparatus faster and faster and faster until the child on this spinning death trap would be flung into the distance. This taught many children, including me, the importance of hanging on tight. 82 years ago, Fritz Zwicky calculated in the Astrophysical Journal that our solar system, similarly, travels around the Milky Way galaxy at over 500,000 miles per hour. So we too should be flung deep into space. But why haven't we? The answer is dark matter. Now, what is dark matter, you ask? Well, picture a child duct taping themselves to the merry-go-round, and you get a pretty good idea. Unfortunately, not much is known about what dark matter is. But a groundbreaking new technology is paving the way for understanding this gripping substance. They call it a DNA tracking chamber, and it promises to take dark matter research in a whole new direction. We will begin by observing the gravity of the background information before directly detecting this new advancement in the field, and finally, publishing some critical implications that underscore the importance of the DNA tracking chamber. So as excited as I am to tell you all about the DNA tracking chamber itself, let's begin by first getting a better understanding of what dark matter is, before second, examining the current research methods available. But first, dark matter. Now, the technical term for a piece of the stuff is a weakly interacting massive particle, or a WIMP for short. Maybe physicists are trying to bully the dark matter into the limelight. You see, the problem with the substance is it's invisible. You can't see it. Light passes straight through it like a ghost passes through walls, but it is there, and a lot of it. We know this because of gravity. Now, because really big objects like the Earth and the Moon attract each other, we can measure how big something is just by seeing how strong the attraction is. The problem is that there is too much gravity and not enough mass in the universe. So, the dark matter accounts for the missing mass. NASA's most recent estimates on June 15th of 2015 say that 84% of all of the matter in the universe is dark. This means that everything that we deal with on a daily basis, the stars in the sky, the room that we are in, the chairs underneath you, accounts for only 16% of the total picture. Now, in a valiant effort to understand the other 84%, many researchers have developed methods to directly study dark matter. Teams such as the ones working at the Cryogenic Dark Matter Search have been leading the hunt for the Holy Grail, direct detection of a WIMP, which I imagine looks something like this. Beep, 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 beep. It's a joke. You can laugh if you want. On April 17th of 2013, they published findings in the Physical Review that stated, with 99.8% confidence, that they had done it. They had found dark matter. Now, while that may sound promising, the scientific community requires confidence levels of 99.9999% to claim this as a discovery. The detector that was being used by the team at the Cryogenic Dark Matter Search just was nowhere near accurate or precise enough. What's more is that the detector needed to be cooled to near absolute zero, which is as cold as it can possibly get. And keeping the detector that cold for years on end doesn't come cheap. Teams such as the ones working at the Cryogenic Dark Matter Search just can't make the detector big enough without also increasing their cost by over 200,000%. So detectors such as this one just won't do. So now that we have observed the gravity of the background information, we can directly detect this new advancement in the field. We'll first see how the DNA tracking chamber works, before second, explore why it is the far superior technology. But first, the DNA tracking chamber works by using, as the name implies, DNA. Now, in case you forgot, DNA is made of 4 base molecules: adenine, guanine, cytosine, and thymine. These are arranged in a very specific order that typically defines what a living thing is. However, because DNA is coded, you can tell exactly where you are on a strand of DNA just by looking at the arrangement of these 4 base molecules. Now, the DNA tracking chamber works by taking thousands and thousands of identical DNA strands, all with different tags on the bottom, and hangs them straight down from a thin sheet of gold foil. Now it uses gold because the atoms themselves are really big, so they make good targets for the WIMPs. Now when a dark matter particle hits the gold foil, it knocks an atom out into this hanging forest of DNA, cutting down strands as it goes. These strands then fall off and are collected in a bin, where molecular biologists are able to analyze exactly where each and every individual strand of DNA broke. So they will therefore use this information to reconstruct the path through the DNA forest, much like how a forensic scientist will reconstruct the path of a bullet at a crime scene. So that's how it works. But here is why it will replace the old-fashioned technology. The biggest reason is because this machine is far more accurate. The distance between two strands of DNA is only a few nanometers. Now for comparison, according to the National Nanotechnology Initiative's website, which is updated daily, a sheet of paper is about 100,000 nanometers thick. So the DNA tracking chamber is mind-bendingly accurate. What's more, it operates at room temperature, so the researchers don't have to pay copious amounts of money just to keep it running. What's more is that the DNA tracking chamber will tell you the speed, the size, and the direction from where your WIMPs originated, unlike the old detectors, which could only report if it encountered one. And it does all of this while weighing less than a liter of water. So now that we know everything that we need to know about the DNA tracking chamber itself, we can publish some critical implications that are associated with it. First, how dark matter itself becomes less dark, and second, it builds a bridge between two disparate fields. But first, dark matter becomes less dark. Now, the mysterious nature of this substance is something that has only added to its legendary nature over the years. People could make as wild of claims as they wanted to about what dark matter is, and they would know just as much as the cutting edge of science. So on June 22nd of 2012, Wired magazine listed some of these. So for example, in Super Mario Galaxy, dark matter is a purplish fluid that disintegrates people on contact. While on Futurama, it's a starship fuel derived from Nibelonian excrement, whatever that means. Now sure, these are joke hypotheses, but these pieces of pop culture reinforce that this is something which was considered impossible to study. People expected dark matter to be dark forever, but now that we have the DNA tracking chamber at our disposal, the opposite is going to be true. In other words, the DNA tracking chamber is allowing us to shed more light on the mystery that is dark matter. But the second critical implication has to do with the research methods themselves. It builds a bridge between two disparate fields, namely astrophysics and biology. Now, these two fields very rarely cross paths because astrophysics is the study of planets, stars, galaxies, and the cold, dead, empty space between them. While biology is, by definition, so full of life. Now, sometimes these two fields are mixed together and referred to as astrobiology, which is the study of life in the universe, but because the only place where life exists is Earth, it's just biology. Despite this, the DNA tracking chamber is giving us a tremendous opportunity to have collaboration between these two disparate fields, because the DNA itself is being used in a very unorthodox fashion. Instead of being used as the instructions for life, the DNA is being used to tell us why life still exists in a galaxy that should have ripped itself apart long ago. So by observing the gravity of the background information, directly detecting this new advancement in the field, we've been able to publish some critical implications that underscore the importance of the DNA tracking chamber itself. This is more than just a fancy piece of scientific instrumentation used to study the universe. It's a way to say thank you to the universe. This poorly named dark matter is responsible for duct taping us to the Milky Way galaxy. So I think I speak for all of us when I say, I am thankful for this ride on the merry-go-round, even if it is a spinning death trap.